Hello, I'm Timothy Helferstay, and this is Logic and Reason. This first episode, CO2's Not Our Doom, is part of a series titled It's Not the End of the World. We're making these videos to help people use logic and reason to see the world is not coming to an end anytime soon. The goal of this channel as a whole is to help people use logic and reason to make decisions. Let's start with looking at this first graph from NASA. In January of 2019, it looks as though we start at a CO2 concentration of roughly 411 parts per million and go to 415 parts per million around May of that same year. When the growing season is in full force, the CO2 concentration begins to drop and we bottom out around 408 parts per million around October of 2019. Once the main growing season is over, the CO2 concentration begins to increase again and ends up peaking out around 417 parts per million in May of 2020. During the main growing season, the CO2 concentration drops again and bottoms out somewhere around 412 parts per million. From this graph, you can see the CO2 concentration increases and decreases in a somewhat consistent manner, which makes sense if you understand the carbon cycle. When everything starts warming up, you have increased decomposition of organic matter, which leads to an increase in the concentration of carbon in the atmosphere. For further clarity, we're going to go over some basic formulas which describe some of the processes in the carbon cycle. First, let's start with photosynthesis. Carbon dioxide and water combine to produce oxygen molecules and a simple sugar called glucose. This is why we observe an increase in oxygen and a decrease in carbon dioxide during the growing season. Not all the glucose will remain as glucose. A large portion of the glucose will combine to form cellulose. Cellulose, which is the main structural component of plant cell walls, will store carbon until it is broken down. Cellulose is typically broken down through three main processes: combustion, aerobic decomposition, and anaerobic decomposition. Although combustion and aerobic decomposition are different, both produce carbon dioxide and water molecules as byproducts. The N at the end of the cellulose molecule is there since cellulose chains vary greatly in length and often contain thousands of cellulose molecules. Anaerobic decomposition of cellulose is typically a greater concern for people worried about carbon emissions since the process produces carbon dioxide and methane. Methane is a much more potent greenhouse gas than carbon dioxide, but it doesn't last too long in the atmosphere because it combines with oxygen to form carbon dioxide and water vapor. Now that we have a better understanding of some of the processes behind the carbon cycle, let's take a deeper dive into why we shouldn't be worried about an increase in carbon emissions at this time. Even though scientists claim we're hitting record highs for the temperature of the planet, the Earth is still attempting to recover from a massive drop in temperature. As seen in this graph, the Earth's temperature is at a low point for at least the last 65 million years. As we recover and warm up, it makes sense that more carbon will be in the atmosphere since warming is a cause for accelerated decomposition of organic matter. As the planet heats up, we're going to start getting longer growing seasons in colder regions, which will lead to a greater decrease in the carbon content in the atmosphere with each growing season. Now let's look at another graph from NASA. Graphs like this are very misleading. One thing to keep in mind is the data from graphs like this often comes from ice samples. There are small pockets of air inside large chunks of ice, which are typically extracted by crushing the ice and measuring the gases which are released. As far as I have found, these tests don't take carbonic acid into account, which inclusion of carbonic acid would make the estimates for CO2 in the atmosphere higher than previously disclosed. Carbonic acid forms naturally when CO2 combines with a water molecule, which makes H2CO3. This loss of CO2 is not accounted for in any of the ice core tests that I have read about, which is a huge oversight that skews the data toward CO2 levels being lower in ice samples. Another thing to keep in mind is that a spike in CO2 could easily be missed in such a long span of time, since each section of this graph spans 100,000 years. Now let's look a little further back than the 800,000 year timeline. This will help you see why some fearmongers don't go too far back with their data. I do have some issues with how some of these dates are determined, but that's a subject for another video. If you look from 65 million years ago to around 34 million years ago, you'll see the CO2 concentration was believed to be much higher than what we have today. Currently, scientists and politicians are telling us we're somehow going to die soon because the CO2 levels will end the planet, even though the CO2 in the atmosphere was significantly higher than our current level for at least 30 million years. This is illogical. Fossil records have shown a history of abundant life and biodiversity. Too much CO2 shouldn't be our concern. we should be more concerned with CO2 levels dropping too low. This will be covered in another video. One last thing for this video I want to cover is that Earth isn't going to have a runaway greenhouse effect, which makes Earth's atmosphere like Venus anytime soon. According to NASA, the atmosphere near the surface of Venus is approximately 96.5% carbon dioxide, and Earth has a CO2 concentration of approximately 0.04%. Now that we established CO2 emissions won't kill everything off, and we learned more about the carbon cycle, the next video will cover why we should want higher CO2 levels in the atmosphere. Once again, this is Timothy Helferstay with Logic and Reason. Be sure to like and subscribe. Thank you.